Continuing with the problem, without resorting to pictures though, we would set, like it says here, the secant line slope equal to the tangent line slope, but this tangent line slope is going to be pi cos pi x, as we just showed. So we now have the equivalence between pi cos pi x on the left, and on the far right 0. So we have this, and we need to solve for x. And those x values that we find, hopefully it'll be a half and 3/2, will be the c values we were talking about from the very beginning. Okay, so let's solve this equation, and hopefully we get the same thing. Picture's pretty convincing. So dividing off by pi, we still have cos pi x equals 0. And we're solving this, we said, for the interval 0 to 2. So x could be any number between 0 and 2, not inclusive apparently from the original context of the problem here, right? We're talking about c values in this interval, so x is in that interval. But the argument is pi x. So what I'll do is I will multiply this by pi. So I'll have pi times 0 is 0, pi x here, and 2 pi here. So this argument inside the cosine function, the whole pi x, should live between 0 and 2 pi. So what values, what angles do make cos equal to 0 between 0 and 2 pi? It should be pretty obvious, pi on 2 and 3 pi on 2. So pi x, the whole argument, should be equal to pi on 2, 3 pi on 2. If we didn't have the context of this interval, then these values would keep going on forever. 5 pi on 2, 7 pi on 2, over here negative pi on 2, negative 3 pi on 2. But because of this consideration here, the only pi x values that live between 0 and 2 pi that have this quality of making cosine 0 are that pi x would equal pi on 2 and 3 pi on 2, the positive and negative y-axis as the terminal side for our angle. So I just divide out by pi now to get x by itself. So this would imply that x equals, dividing by pi we get a half and 3/2, the same two answers we had just judging everything by the picture. So in this case, the mean value theorem again. The mean value theorem says there must be at least one location where the slope of the secant line for the interval, in this case 0, 2, will be the same as the slope of the tangent line somewhere between 0 and 2. In this case there were two locations. At 1/2 the tangent line has the same slope as the secant, and at 3/2 the tangent line has the same slope as the secant. So those are our two values, and that is the analytical approach.